Alright, let's see what we got. Valid Sudoku. Determine a 9x9 Sudoku board. If it's 9x9 Sudoku board is valid, only the filled cells need to be validated according to the following rules. Each row must contain digits 1 through 9 without repetition. Each column does the same. Each 9 3x3 subboxes of the grid must contain the same. Sudoku board partially filled could be valid, but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. So there's dots there's a 2D array of strings of 5 or strings of digits or dots or space for empty spots. Okay, so it's a medium, huh? I guess I solved it previously or something. Okay, looks like it might be backtracking. Would this be backtracking? So what to do here? Like I could go through every constraint of row, column, or subgrid, sub box, and choose one item from the possible set of values, and then iterate over. What to do? So if I go over every row, then like I randomly choose an option at any particular spot in the row. Randomly choose a spot. Okay. Every cell has constraint of row, column, and sub box associated with it. If it's solvable, A Sudoku board partially filled could be valid, but is not necessarily solvable. And I'm returning whether or not it's valid, right? Determine if it's valid, yeah. Okay. Can I what is the backtracking method here? If I go through each row, okay, so if I think of this subgrid, it only has 4 things left in it. 1, 2, 4, 7. And then I arbitrarily actually, if I consider this cell as having some number of possibilities, like 1, 2, 4, 7 is already removed from the cell. because of this thing. So 1 or 2. Does it make sense for me to try to always consider that this subgrid, subbox, I'm trying to consider all the constraints that have been applied or just one set? Okay. For each cell, the set of things that are possible at that cell is initially everything, and then, or if it's already filled, then it's just that number. And for each cell, once you place a number, you remove. Once you place a number, you remove every row, column, subbox that's associated with it. And then if you remove the last one, remove the last possibility from a box, it's impossible. What technique? What technique? Alright, let's just try something here. Let's go possibilities is going to be a 2D array. Guess it's going to be a 2D array of 1 through 9 for every spot. A set from 1 through 9 for every spot. Set 1 through 9. Or it could just be an array of false. Set would be easier to check if there's anything left. Guess maybe a set. Okay, possibilities. It's gonna be, I have to create a new set each time. Let's just go 1, 2, 3. Well, I know it's 9 by 9, so I'm just gonna hard code that. For length and range of 9. So that's a set. I think actually, so let's go by 3 by 3. I think this is gonna be that, and then maybe an extra bracket for, let's say, R. Actually, this is columns. R in range 3. Just want to make sure this is the correct 3 by 3 of sets that are 1, 2, 3. Three by 3 with sets that are 1, 2, 3. Missing a closing parentheses. Whoops. Okay, 1, 2, 3, and this is like row 1. row 2, row 3. Okay, I think those are correct. And if I did something like pos at row 0, column 0, or actually row 0, column 1, remove element 2. Row 0, column 1. Row 0, column 1 is there. Okay, I think that's what I want. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 by 9 of that. Okay. And then if I go through the whole 2D array and okay. Wonder. We want to make some sort of data structure for like each row. And then each column. So this is the cells of the actual thing that I'm trying to fill out. Then maybe I have a, would it make it faster to check? So if I fill out this spot, so this spot would have a set that is like 3, 5, 7. And then if I fill out this spot, then it removes it from this row, it removes it from this column, and it removes it from this sub box. So constraint rows sets, constraint row sets, and then constraint column sets. Does that make sense? Guess so. Say constraint R constraint rows. What's another word for constraint? Synonym constraint. Restriction curb check row, check rows. So this would be a set of values for every row. So it'd just be a 1D array, I guess, or a 1D array of row sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, or something in the range of 9. And then check columns is the same. And one last one for the sub boxes. Check sub. Check sub box. Maybe I call it boxes. Box. Sure. then I go through every element of the current board and assign them to the spot in the board, which will fix the possibility to be a set possibility for that spot, and then remove them from the corresponding rows and columns. But maybe I need to do a assign sub function. So assign may be at a certain row, column, and a value. And this should actually maybe the possibility is erased, not necessarily. Okay, so if it assigns it, then that means the check rows, should it? Maybe, so let's go with it. The check rows at this row should remove this value. The check columns at this column should remove this value. And then the checkbox. So assuming that the ordering is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8 for the boxes, then that means the row and column combination to get the box would be row times 3 plus column is the box index. So if it's like row 1, column 0, 1 times 3 is 3 plus 0 is 3. So that's the subbox index. So check box at 3 times row plus column, remove the value. I wonder if I need to verify that that value can be removed from that constraint. I guess assignment is probably, like, I can make an if statement here and check to see if it's actually there. Say Python remove set. And I think discard and remove are the two versions. Remove, if the element is not found within the set, remove raises a key error. I could maybe use the key error as a way to identify that it's not possible. Probably don't want to do that, but okay, I think this is fine. So I go through for every row in range 9, and then for every column index in range 9. If the board at this row column is 1, then just ignore it. Otherwise, the value is going to be, let's say, offset is going to be the ordinal value of a 0. The value in numerical terms is going to be the board at this row column, the character version of that minus the offset, and then I'm going to assign to this spot this value. Alright, I think let's go print out check rows, print out check columns, and print out check boxes. String to integer. Oh, whoops, yeah, it's going to be ordinal of the character. The character digit minus ordinal of the 0. Check boxes. This is incorrect, really? For every, oh, yeah, that's right. So the row, I see, whoops, that math was incorrect. This is column 0, 1, 2, 3, 4, 5. So the row, the sub box, oh, that's really wrong. So row 0, 1, 2 maps to sub box with row 0. So I think it's actually row divided by 3. And then the column 0, 1, 2 maps to column 0. Was it divide by 3 both ways? Column 0, 1, 2 maps to subbox column 0. Columns 4, 5, 6 maps column, yeah, okay. Still wrong. Row 0, row 0, 0, 1, row 2. That might be right. Okay, so what's going on here? Still this thing, oh, it's not plus. It's this thing divided by 3 and then still multiplied by 3 actually. Yeah. Row 0. That's still wrong, huh? Okay, let's go ahead and just print out what I think is, or what is it calculating. Okay, yeah. So 0, 0, 8. So 0, 0, 8. That seems like it'd be the wrong first value. Is this doing this board? Okay. 0, 0, 8 is in rows in sub box 0. That's fine. 0, 0, 0, 1, 3 is in sub box 0. 7 should be in sub box 1. 106 is sub box 0. 195 also box 1. 98 sub box 0. 9, 8, subbox 0, and then it should probably be doing subbox. This one 6. 6 should be in subbox 0, 1, 2. It crashes before it does 6, I think. So it's crashing on this one, I think. Subbox 0. Oh, it's crashing because it's not valid. Okay, I see. So the assignment there is false. Okay, so it could already, I thought it would be like, thought the assignment could be bad, or the assignment could not be bad. Like there was some other thing that you had to figure out. Okay, actually, so I guess assigning here is if there's an error, then you can just return false. So I guess you can do a try here. And then do an accept. And here just return false, return true. And then here, if not this, then return false. If it's not valid to assign it, then okay, so that's take care of that. Otherwise, the assignment is fine. Okay, so these are the row constraints after I removed the appropriate stuff. Okay. Well, these are the row, column, and subbox constraints. So the first row has these possibilities, second row has these possibilities, third row has those. First column, second column, third column, so on. First subbox, second subbox. So I don't think I need the possibility 2D array. I'm using just single. I'm using an array for each type of constraint. Alright, so the next thing would be to, wait, is that it? Only the filled cells need to be validated according to the button. Oh my god. I'm making this much more difficult than I thought. I thought I need to actually like solve the thing. So if it's not false, then just return true. Wow, that's so overcomplicating it. Oh my god. Okay. Was there a better way of doing this then? Yeah, so I guess if I didn't have to worry about that, then I could just make a empty set to start with, where the empty set can't have duplicates. Yeah, I guess if I am not trying to solve it, I don't really care about the possibilities that I'm removing. Okay, so check rows. just start with an empty set. I'm not sure if this is actually faster. But it should take less memory at least. That's current memory usage. Current memory usage is 17.8 megabytes. So start with an empty set and then assign. And here, I don't think I need recognize. So if the value is in check rows of that row, then return false. I guess I could do an if statement or the values in check columns of the column or the values in check box for row divided by 3 times 3 plus column divided by 3. If it's in any of those, then return false. Otherwise, add it to those things. And return true. And if not assigned, then return false. Okay. Okay. That was faster for sure. And 0.02 megabytes less. Okay. What's the Pythonic way of indenting this? Oh my gosh, I should Pythonic indentation of multiple conditions in if statement. Across lines. If condition using a parentheses for implicit line joining. Okay, so it's if this or and then indented. Okay, I guess that's it. Guess this is, and there's no way I'm going to remember that without doing a lot of Python coding like every fucking day. Routinely using that. Okay. Alright, I'm going to assume that this is all random. Okay. Summary. Given that the problem is not asking to find a valid solution or check whether a valid solution is possible / exists, but only to verify that none of the constraints for rows, columns, and subboxes are broken by the initial set of values. It is much simpler to design an algorithm. No need for backtracking, kind of guess and check stuff. So to verify that none of the constraints are broken, can create sets for each constraint. So example, a set for the first row, second row, etc. And if a numbers are added to the set numbers, okay, each grid position value is added to the sets that apply to it. So since each position corresponds to a row set, column set, and subbox set, if when adding, check that the value hasn't already been included in that set, which would indicate that the constraint is bad. Grid is invalid. So for example, if adding 1 to, or let's say adding 5 to a row set 1 and 5 is already there, that means that constraint is broken. So in summary, create the row sets, the column sets, and subbox sets as 1D array of sets, where index into the array is the particular row, column, box index. Iterate over the positions of the 2D array grid and assign the value at that position to the corresponding sets, while checking for invalid constraints. Note that the row and column need to have some logic, some calculation logic to match to a subbox index. So that would be this thing here. For the above, it used subbox is equal to that. So anything that's a row 0 through 9, or 1 through 9, 0 through 8, column 0 through 8 would correspond to a subbox 0 through 8. Also, note that since the grid has strings of digits, need to convert those into integers. Actually, I guess that's optional, really. I guess optionally, I also say optionally I convert those. Because I could have used a set of strings, where the set of strings is string 1, 2, 3, 4, 5, 6, 7, 8, 9, and would still have actually, I guess I could have used an array of 9 false values rather than sets. Actually, yeah. Now that I think about it, might have been better to use an array of booleans rather than sets. Originally, the original intention of sets was to make it easier to identify when there was no more possibilities using length of the set when working on a backtracking solution. So yeah, I probably would use 1D array of booleans, set the boolean to true, to add it to that set, to add it to that constraint, and then before that check to see if it's already true, to check that it's if it's a valid adding. Whatever. Time complexity gonna be O of this might be constant actually. O of n squared. Where n is the size of the Sudoku box. In theory, this would be constant, since n, I guess not in theory, can interpret this to be constant if n equals 9. In theory, can extend Sudoku type kind of constraints to more, not more dimensions, but to longer dimensions, like example 13 by 13 Sudoku. I guess 13 by 13 doesn't have a subbox. Say 25 by 25 Sudoku. In which case the speed appropriately, the time appropriately increases to do this algorithm. Space complexity, this is going to be O of n squared for the sets involved, which are corresponding to the number of values.